Hello students. Today we will do one question. The question states as if there are 10 to the power 9 electrons which are moving from one body to other body in 1 second, then how much time is required to get a total charge of 1 coulomb on the other body? So we are having these two bodies, one this and one is this. This is body number 1, this is body number 2. From body number 1, 10 to the power 9 electrons are moving. And the time given is 1 second. Moving to the other body, on the body number 2. Okay. So time taken by one electron to move to the body number 2 is 1 to the 1 by 10 to the power 9 seconds. So solving it out, 10 to the power 9 electrons take 1 second. So 1 electron takes how many seconds? Cross multiply it and you will get the answer 1 by 10 to the power 9 seconds. So this is the time for one electron to go from body number 1 to body number 2. Now how many electrons will constitute 1 coulomb of charge? This is the second step. We will learn, like we know 1 electron is having charge equals to how much? 1.6 into 10 to the power minus 19 coulombs. So number of electrons we have is 10 to the power 9 electrons. So in 10 to the power 9 electrons, how much charge will be there? It will be 1.6 into 10 to the power minus 19 coulomb into the number of electrons we have, that is 10 to the power 9. When one is having this, 2 will have 2 multiplied by this number, 3 will have 3 multiplied by this number. Okay. So the answer we get over here is 1.6 into 10 to the power minus 10 coulombs. This is the amount of charge that will be carried from body 1 to 2 in 1 second. What is the amount of charge? That is 1.6 into 10 to the power minus 10 coulombs. Now this is the charge for these many electrons. Now for 1 coulomb, x electrons are moving from body number 1 to body number 2. So in these x electron, what should be the amount of the charge? It should be 1 coulomb. Okay. And for 10 to the power 9 electron, what is the charge we are getting? That is 10 to the power, that is 1.6 into 10 to the power minus 10 coulomb. Again, cross multiplying it, we will get x electrons equals to 6.24 into 10 to the power plus 18 electrons. So that is the amount of electrons. X equals to 6.24 into 10 to the power 18 is the amount of electrons that we need to pass from body 1 to body 2 so that body 2 will have charge equals to 1 coulomb. Okay, so you got the answer from where we are getting number of electrons. We are getting through this procedure. Okay, through this procedure. Now, time taken for these many electrons to pass from body 1 to body 2 will be calculated as we have calculated in these steps. Okay, same. So, for 10 to the power 9, time taken is 1 second, and hence for 6.242 into 10 to the power 18 electrons, time taken is x. Cross multiply it and you will receive an answer as 6.24, 2 into 10 to the power 9 seconds. This is the time taken by 6.242 into 10 to the power 18 electrons to pass from body number 1 to body number 2, so that the body number 2 can acquire a charge of 1 coulombs. Now the answer which we received is in seconds. Okay, is in seconds. We need to convert it into years. For converting into years, this number is divided by 60. That is, for converting these second into minutes, again 60 to convert these minutes into hours, then 24 to convert this hour into day, and then 365 to convert these many days into years. After calculating this, we will find the summed up answer comes around 198 years. So, in order to get a charge of 1 coulomb on body number 2, we need approximate 198 years. Okay, so this is a huge amount of years, like huge amount of time, which is taken by the body number 2 to acquire a charge of 1 coulomb. And from this particular exercise, we are getting a conclusion that the charge of 1 coulomb is a very huge quantity. As we have studied while we were reading about the charges, we have read in our electronic devices, what we use are microcoulomb, or millicoulomb. Okay, we never use the statement of coulombs. Why? Because this is a very huge amount. So hopefully this exercise is clear to you, and here the question ends.